Good morning, everybody, and welcome to this Euresys presentation. So today we talk about deep learning-based libraries running on embedded systems. I will start the presentation with a very short introduction about Euresys company, explaining who we are and what we are doing. I will then talk about the advantages of using deep learning tool for vision application. I will also explain why it makes sense to use embedded systems for vision applications. And finally, as a conclusion, we will see some examples of deep learning-based application running on embedded systems. But let's start with the presentation about Euresys. So we are manufacturer of machine vision components. Euresys is a Belgian company. The headquarters is located in Liège. We have R&D teams in Belgium and in Germany. Euresys has also sales and support offices in Europe, USA, Singapore, China, and Japan. Euresys benefits from an extensive network of distributors, and we are renowned for providing high quality product and premium supports to OEMs and system integrators. So at Euresys, we offer three types of product. We are, of course, very well known for our frame grabbers that have been used in the vision industry for more than 30 years now. But in addition to frame grabber, we also develop and produce IP cores for various interface standards and imaging sensors. We also provide a complete range of machine vision software libraries that are known as OpenVision. And those libraries are dedicated to the development of 2D, 3D, and deep learning-based applications. So deep learning is a trendy subject in computer vision. All major actors in this field are proposing deep learning-based solution or components. And one of the reasons for that is because the deep learning approach opens up new opportunities in various domains where conventional algorithms simply fail to provide stable and reliable solutions. The fact that those deep learning tools can now also run on embedded platform makes them even more appealing. So let's dive into this subject. The deep learning tools can be used in various kinds of vision applications. And I would like to start with a review of some applications where it would be very difficult or even impossible to solve them using conventional algorithm. For instance, vegetable sorting or fruit sorting is a good example where the deep learning approach should be preferred. Mother Nature can be very inventive when it comes to the color, the size, or the shape of fruits or vegetables. And typically conventional algorithms have some hard time to deal with such variations. In the textile industry, an interesting application for deep learning is the accurate defect segmentation on fabrics. And this one is my favorite. The detection and the identification of foreign material in coffee beans. Frankly speaking, how would you solve this problem using a conventional algorithm? Deep learning can be used to count objects. So in this example here, we see electronic components that can overlap, and they are placed in plastic bags, which are highly reflective, but still we're able to count them. Deep learning can also be used to localize objects, even if they overlap and have different color shades. Referring to this image, when it is processed by a conventional algorithm, the number of objects in this image has a significant impact on the processing time, which is not the case when using a deep learning tool. The deep learning approach offers several advantages, and the first one is data-driven, which means that unlike rule-based algorithm, where we must provide a detailed description of the object or the defects we are searching for, in case of deep learning, we just need to train the neural network with a dataset of images featuring these objects or defects. So suppose we must develop an application to classify small stones as good or defective. If we want this application to identify spots of glue on stone or broken stones, the deep learning approach, we just need to train neural network with a data set featuring images of good stones, stones with glue, or broken stones. So it is pretty straightforward. There is no need to write a complex algorithm to describe how a good stone will look like, or a broken stone, or a stone with glue would look like. So the deep learning approach also reduces integration cost by allowing easier and faster application development. In terms of programming, since we don't have to write code to describe in detail what is considered as a defect, the development of a deep learning-based application is easier and much faster. Another great advantage of the deep learning approach concerns the maintenance and the evolution of deep learning-based application. So if we refer again to our small stone classification example, if we want this application to detect a new type of defect, this evolution just requires adding images of this new defect in the dataset and then train the neural network again. And there we go. The application is now able to take into account this new defect without the modification of a single line of code. And this is the most important point here, without the modification of a single line of code. If you need to apply the same evolution to an application which is based on conventional algorithm, well, you have to be prepared to rewrite a significant part of your code. There are basically three families of deep learning tools. We have classifiers, segmenters, and object detectors. And at Euresys, all those tools are gathered in the deep learning bundle, which is part of the OpenVision software package. The Euresys software library for deep learning classification is called EasyClassify. It is used to detect defective product or to sort product into various classes. EasyClassify supports data augmentation, and for the training of its neural network, of as few as 100 images per class are sufficient. So EasyClassify, of course, is compatible with CPU and GPU processing. For the deep learning segmentation, we provide a library called EasySegment. Two operating modes are available. The first one is called unsupervised segmentation. In this case, the neural network is trained with images of good sample only. And in this case, the EasySegment unsupervised detect anomalies or differences compared to the model it has learned. The unsupervised segmentation is very useful when defects are not predictable. For instance, a defect that might occur due to the aging of a machine. The other operating mode is the supervised segmentation, which is also called semantic segmentation. In this case, the neural network is trained with annotated images. EasySegment supervised allows to achieve a very accurate pixel level segmentation. And finally, the last tool is called EasyLocate. It is used for the localization and classification based on deep learning. EasyLocate can be used to localize and to identify product, object, or defects, even if they overlap, and therefore it's also able to count them. Just like EasySegment supervised, EasyLocate must be trained with annotated images. The annotation is a bit more easier, let's say, with EasyLocate. We provide two modes for the annotation. The first one just requires placing bounding box around each object to learn. And the second mode, which corresponds to our brand new tool, which is called EasyLocate Interest Point. This mode should be used when all objects feature approximately the same size. And in this case, just clicking the center of each object is sufficient to perform the annotation. So EasyLocate Interest Point really simplifies the annotation. So in addition to our deep learning libraries, we also provide an evaluation and prototyping tool, which is called Deep Learning Studio. So Deep Learning Studio is absolutely free. You can download it from the Euresys website. It allows to create datasets, annotate images, manage the data augmentation and the dataset splitting. You can also train the neural network and then analyze the results of the training. Finally, Deep Learning Studio can also be used to test the robustness of our easy classify, easy segment, and easy locate libraries. So once the neural network has been validated using Deep Learning Studio, it can be exported to a file. And this file is cross-platform, which means that it can be loaded in an application which is running on a Windows PC, a Linux PC, or on an embedded platform. So now let's talk about embedded system, which is also another trendy subject in computer vision. So in this section, we will review some advantages of embedded systems that explain why they are more and more popular in vision applications. So maybe the most obvious advantage of embedded system is that they are compact. So they are easily installed on production line. The fact that they are compact also makes them suitable for mobile setups. Using embedded system is usually a cost-effective solution. Here we see a picture of Raspberry Pi 4. A few months ago, this device was available for, let's say, 30 euro. Nowadays, of course, with the global electronic component shortage, the price of the Raspberry Pi 4 is around 150 euro, but it is still significantly cheaper than a regular PC. Embedded system can combine image acquisition and image processing in single compact housing. Putting the processing close to the sensor has some advantages. For instance, it avoids image transfer and therefore reduces the latency. It also simplifies the setup because there is no need for a separate PC to do the image processing. And in terms of cabling, it is also much easier. Power efficiency is another concern that becomes very important these days. And in this regard, embedded systems bring a solution because they consume less power than regular PC. Of course, I'm not saying that embedded system can replace all PCs in the vision industry. For high-end applications that require a lot of processing power, industrial PC are still the preferred solution. But there are a lot of applications for which the processing power of embedded system is more than sufficient. All the OpenVision software tools support embedded platforms that are equipped with processors from the ARM v8a series. ARM v8a is an architecture which is used on many embedded systems today. In terms of memory to be supported by OpenVision, these devices should feature at least 512 megabytes of RAM and 512 megabytes of storage. So these embedded systems should also run on a Linux 64-bit operating system. So here we see a list of devices. It's a non-exhaustive list. And those devices, they comply with these requirements. So they are therefore supported by OpenVision. So let me conclude this presentation with some example of vision application running on embedded systems that are using deep learning tools. Thanks to their low power consumption, embedded systems are suitable for handheld devices. And in this example, we use a Raspberry Pi Zero to read digits on a water meter. The Raspberry Pi Zero has only 512 megabytes of RAM, but it is still, it allows to use our easy OCR2 library to read characters. The character recognition is based on a deep learning classifier in this case. So the application looks like this. We see that characters are detected. And each character is surrounded by a bounding box. So the character are recognized, as I have said, by a deep learning classifier, which also means that for this vision application, there is no need to learn characters beforehand. Embedded systems can also be used in the pharmaceutical industry. And in this second example, we use a Raspberry Pi device again. This time it's a Raspberry Pi 4, which is a bit more powerful than the previous one. This one features 5 GB of memory. And for the image acquisition, we use a 12 megapixel camera. It's a board camera which is connected to the CSI port of the Raspberry Pi board. So in this application, we have to read a serial number, an expiry date, and a lot number. And to do so, we also use our EasyOCR2 library. Again, the character recognition is based on a deep learning classifier. We also use for this application our Easy Matrix Code library for the detection and the decoding of the data matrix code. And the whole process, so character recognition and matrix code reading, takes approximately 300 milliseconds. And then finally, our last example. Here we have a Bomer VAX50C camera, and it is used to run our Easy Segment library. This Bomer camera is a 5 megapixel color camera. It is equipped with an NVIDIA Jetson Xavier GPU, and it features 8 GB of memory. So the application that we have here, the goal is to detect foreign materials in coffee beans, and to do so, our Easy Segment library is used in supervised mode. So the processing time in this case is approximately 200 milliseconds. And to achieve this performance, the Easy Segment neural network has been trained with approximately 150 annotated images. And this is the end of my presentation.
Okay. So if there are any questions, please use the Q&A section, and it's started. Okay, when using AI, is it better to have more images? Is it better to have more images as possible as data set, or will this confuse the system, and it is better to keep sufficient number of images?
So I would say that the more images you provide to the neural network to do the training, the better. But of course, the images must be really representative of what the system will have to face in the real life. Depending on the complexity of the image, you may have to provide a lot of these images. You have also to make sure that the image that you are providing will not confuse the neural network. So as I said, you have to annotate correctly the images, but yeah, as many images as possible, it's okay.
And can you give an indication about the OCR speed with embedded boards as characters per second?
Well, the example that we have here, I go back to this one here. So as I said, for this one, for the whole process.
I can't see your presentation.
You don't see it again? Oh, okay. So here.
Yeah, now I can see it.
Yeah, for this application, the whole process takes 300 milliseconds for reading all the characters and the and detection of the data matrix code. So I don't have really figure about how much time it takes to detect, let's say, 10 characters, but it's just to give you an idea.
Maybe you can write your email address to the chat so you are able to get in contact with this person, and you can send him more data afterwards.